Let's do a 3-line example solve. I'm going to start memorizing corners and then edges, and we'll go on to execution, which of course is edges and then corners. My starting buffers are UFR and UF, and we will continue from there. We're going to start from UFR. We go here, then here. That's going to conclude a even-oriented cycle since we landed on the white sticker of our buffer, which indicates that this, which basically is our only indicator of oriented cycles. Not our only, but it's what I would use. Go UFL. We go 1, 2, and we run into a special, very special case known as a floating LTCT algorithm. There are a lot of them, of course, if you excuse UFR LTCT, the standard for LTCT, you get around, I'm not even sure honestly myself, there are way too many. There's definitely over twice the amount of algorithms there are in LTCT, standard LTCT for floating. However, this subset is very conventional. We have UFL to UBL and LDF as our twisted corner. Of course, there are other ways to go about this, what would be known as a UFL LTCT. There's of course the way of going to UBL and then breaking to this twisted corner, which assuming you go from UFL to UBL and then break to LDF, so you can have a oriented, so you can have white on the bottom. You can end up with something like this. A floating two-corner parity algorithm with UF and UR swapped. It's not the most conventional thing you can do, but if you are low on algorithm knowledge, yeah, I would strongly suggest just to do something, just to think of something and just go for it. Though, of course, the more conventional thing to do is, of course, something that is, of course, engaged in an algorithm set that reduces your algorithm count by 1. So, now we can move on to edges. We can go from here to here, here, and here. Keep in mind that we're going to have UF and UL pseudo-swapped. Now, unfortunately, with my 3-line progress so far, I am not completely used to the concept of D-line floating or D-line tracing for edges primarily. So in that case, I'm going to break into what I would probably see first, going onto edges, like going to the tracing the first column. You see this very convenient, odd oriented cycle, which is just a 2 swap. So I'm gonna conventionally break from UFDL all the way to UB, which is a 6 mover. And then of course we can go to RU to back to UB. Now, keep in mind that there is a flip, an edge flip right here. Fortunately, I probably would be able to notice that immediately, right away, and save that last column that would solve these two, and break into this this edge flip. Additionally, after that, I want you to notice that there are 3 edges left to be solved. We have DF to BL to RB. I would probably do that algorithm first since it's the least conventional, least turning conventional algorithm in this entire solve. So we can start by doing that algorithm. Now going on to UF. Now going into this commutator that breaks into UB. Now we can break into this edge flip. Keep in mind that there are 2 possible ways we can go about doing this first algorithm. What I would do in this situation is note that this alg is not one of my favorites. So I'd probably disregard UF to RU to LF and go straight into UF RU FL. And then keep in mind you would choose the opposite sticker, LF, back to BU, assuming you traced well and did not mess up. Now going on to corners, we get UFR to DF to DBL to RDF. We get UFL to UBR to DBR. And now we get this LTCT case, floating LTCT. We can cancel into this alg by disregarding this post move and beginning the algorithm, which begins in U prime D. Conventionally, we have the U prime already done. We can just do the D